Good day, everyone. Today we will be diving into a fundamental concept in operating system, the shortest remaining time first, also known as the SRTF scheduling algorithm. So, this is a preemptive strategy designed to prioritize efficiency by focusing on how much work a process has left to do. So, before we proceed, let's start a question first. What is CPU scheduling? So, CPU scheduling is a fundamental operating system function that determines which process gets access to the CPU for how long. So, CPU is the goal of any scheduler is to keep the CPU as busy as possible to reduce the delays for the user. So and ensure also that the system resources are distributed fairly and effectively. So let's go to the SRTF. So SRTF, or shortest remaining time first, is a preemptive version of a shortest job first. So while shortest job first waits for a process to finish once it starts, shortest remaining time first is a dynamic. It constantly asks, is there a process in the queue that can finish faster than the one I'm running right now? Yeah, so here the shortest remaining time first has a key characteristics. So the preemptive and the dynamic one. So the preemptive, it preempts the current process if a new process arrives with shortest remaining time. So the dynamic, it continuously evaluates remaining execution time for of all processes. So the shortest remaining time first versus the short job first. So the RTF, it has a preempts running process if a shorter process arrives, while SJF, once it started, the process runs to completion. So the SRTF also have a optimizes for minimum average waiting time and more complex implementation, while SJF has a simple implementation only and less optimal average waiting time. So let's go to the core principle of SRTF. So here the defining characteristic here is the preemption. So SRTF preemptive, meaning it can interrupt a currently running process if a new process arrives with a shorter remaining execution time. So if a new process arrives and its remaining execution time is shorter than the remaining time of the current process, so here the CPU will immediately interrupt the current process and switch to the newcomer. This ensures that the CPU is always working on the task that is closest to completion. So the SRTF algorithm workflow. So first, how does this look in practice? So it has a 5-step cycle. First is the process arrival, which it enters and ready to queue. So the second is the remaining time evaluation. So the remaining time evaluation, the scheduler evaluates the remaining time for all the processes. And the third one is the shortest remaining time selection. That is the one with the shortest time is selected. So the preemption context switch. If it's a different process than the one running, a context automatically switch occurs. So the last one is the execution and authorization. The process here is the process will execute and its remaining time is decrement and the cycle repeats until the tasks are finished. So that is how the algorithm of SRTF works. So it it goes first to the process arrival, next to the remaining time evaluation, to the shortest remaining time selection, preemption and context switch, and the last one is the execution and authorization. So here we have the example of the process setup. So let's look at a quick example with the four process. So P1, so here P1 through P4 at time 0, P1 start with 8 ms. At time 0, the P1 start with a 8 ms. So but at time 1 here is the P2 arrives with only 4 ms. So since 4 is less than P1's remaining 7 ms, so the CPU preempts P1 and switches to P2. So we follow this logic until it all processes complete. So next here is the execution analysis. So in this specific scenario, we are achieve an average waiting time of 5 ms. This is the biggest selling point of SRTF. It is mathematically proven to be optimal for minimize average waiting time. So here we got the advantages and the disadvantages. So however, there is no such thing as a free lunch. So here we have the advantages, the minimized average waiting time and the good responsiveness. So it provides excellent responsiveness for a short process. So the disadvantage here is the starvation of long processes, difficult to predict burst time, high overhead due to context switching. So it can cause the starvation if short processes keeps arriving and a long process might never get to run. So the advantage here is to proven to be optimal in minimizing the average waiting time for a given set of process, and shortest processes are handled very quickly, improving the system's responsiveness. While the disadvantage here, the longer processes may be indefinitely delayed if a continuous stream of shorter processes keeps arriving. So it requires a accurate knowledge of the remaining execution time for each process, and frequent context switches consume valuable CPU time and increase system overhead. So the technical challenge here is that it's hard to predict exactly how much the burst time a process has left, and the frequent context switching adds overhead that can slow the system down. So here the comparative analysis with other algorithms. So compared to the first come first serve, also known as FCFS or round robin, SRTF is more complex to implement but offers the best theoretical wait times. While FCFS is simple, it can lead a convoy effect where everyone waits behind one long process. So SRTF is theoretically optimal for minimizing average waiting time but faces practical implementation challenges. So the practical challenges here is the burst time prediction, starvation risk, context switch overhead. So the suitable applications are the batch system, time critical system, and influence modern algorithms. So while SRTF faces practical hurdles like burst time, starvation risk, context switching overhead, it remains a gold standard for performance benchmark. Its principles, prioritizing short tasks and using preemption, continue to influence modern adaptive scheduling algorithms used in systems today, So that's all.